Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Thanks for joining us here today, everyone. Today, we're going to be talking about a topic that Honorio actually suggested as well, immutability, state, and scaling. Before we get into the topic, though, we'll just go ahead and go around and maybe just do some brief introductions. I'll kick it off. My name is Ray Welker. Again, I'm here cloud engineer or cloud solutions engineer at Right Brain Network. I do a lot of work with AWS infrastructure, a little bit with architecting and designing, solutions for our clients. So that's a little bit about me. Kevin or another person on here, would you like to go next?
Sure. My name is Kevin Lucas. I am a cloud solutions architect for Right Brain Networks. Similar to Ray, work on designing and implementing various things, mostly in AWS, with, I guess you could say, a specialty on the infrastructure side, but I pretty much do a bit of everything.
Honorio or Tom, would you like to just give a brief introduction, or Howell?
If you want to, Tom, go ahead.
Sure, yeah. Been a couple of these. Tom, Daysmart Software, chief architect over there. Just do a lot of things, strategy, infrastructure, technology related. So, very familiar with AWS and the things, and excited to talk about this.
Awesome.
Cool. And my name is Honorio Kanachi, software engineer for my Matt. It's funny. I suggested this. I was just looking at something recently, and I'll send you guys a link. It just reminded me of a talk that Joe Armstrong had given back in 2013. And I'll hold that thought until we get ready to discuss. But anyway, well, I'm glad to be here finally.
Great. Yeah, we're definitely glad to have you. Owl, did you want to give an introduction, or should we go into the talk now?
We can go to the talk. I'm IT, know just enough in AWS to be dangerous, but very interested in security. That's
awesome.
Right, yeah.
Cool. Yeah, looks like we had a group of pretty diverse backgrounds in what we've been doing here. So I guess wanting to kick it off, we're wanting to talk about immutability, state, and scaling. I think it probably makes sense to maybe talk about immutability first. With that, I mean, that's kind of the idea of, write once, read many. Is there anything that you specifically wanted to kind of delve into, Honorio, or I kind of want to open up the floor to what people's thoughts are about this. I know that you're primarily in software development. Kind of our expertise here on our end is a little more on the infrastructure side, but using AWS for software needs and sometimes even re-architecting software. But is there anything that you specifically would like to touch on here initially?
Oh, sure. To me, it's like AWS and the idea of immutability kind of dovetail into one another, because the whole point of immutability, and when I say immutability, I want to kind of make sure I'm level setting here. When I talk about immutability, what I'm talking about is you will, when you do a variable in a programming language, basically what you're doing is you're naming a memory location. Like if I say X equals 1, I'm literally saying memory location 1000 is now called X, and I'm storing 1 in there, right?
Mm-hmm.
Immutability is basically like, okay, I can say, now I could come along and say now X equals 2, but I could not go back to that memory location of 1000. I would have to go to a different memory location and write a different X, right?
Mhm.
And this solves so many problems with having to lock things and having two people trying to go after the same piece of memory, because it just doesn't happen. You can't modify that memory once you've set it to something, right?
Mhm.
And so, to me, again, when you look at like scaling, in terms of scaling, what I started to say earlier was I was rewatching an old presentation from Joe Armstrong, who was one of the 3 people who created Erlang, and he was saying something about one of the points he mentioned, which I thought was really interesting. Like 50%, and this was in 2013, of the world's mobile phone traffic goes through Erlang. That is, to me, is astonishing. You think of, I mean, I can't think of anything else. I could say 50% of the world's software is involved with this. That's
Wow.
just astonishing scalability. And his point was isolation is extremely important for scaling, which is that same idea of immutability. Like, I don't want 2 things going after the same thing. I want, those 2 things isolated from one another. And to me, when you talk about scaling up, you talk about AWS and, hey, I want to throw more cores at this, or I want to throw more memory at this, or whatever. If you do that without worrying about how am I isolating these new things from old things, then you're running into problems, because, a lot of software developers, a lot of IT people aren't accustomed to thinking of things in terms of like having to deal with the case that your variable might just be pulled off from under you,
Mhm.
which is a thing that you could happen in, like, in a lot of cases, because like, hey, I'm writing to this machine and all of a sudden this machine is gone. We're not used to thinking that way.
Yeah, and I think
I hope I'm getting my point across.
Oh, do you have a
yeah,
comment?
definitely. I think that's actually a big thing, and that's something we see on a lot of our projects. I think one of the biggest mistakes I see companies make is they'll set up these environments for their developers, and like they'll go to deploy their app, but because it's dev, it's not super high traffic, they basically set it to only one instance. And the app runs fine with a single copy of itself running, where all the traffic goes to that one copy of the app. And then you get, you're a month out from release, and people only then start talking about, we need to figure out scaling for this thing. And suddenly we're running 2 copies of the app and we get all these errors because, like you said, the app was never tested to no one ever did the testing to make sure that it was written in such a way that it could handle this node disappeared or this request got routed to another node, and suddenly those nodes don't have access to that data.
Mhm. So that's kind of like the whole idea of, right, creating like an asynchronous app and ensuring that no matter how many copies, right, we're able to scale and pull from these locations of where the data is when we need it, and how to handle like sharing these requests over X number of instances of that app running. I mean, just in general, like using immutability, what you'd need to do with state and scaling like that allows you to leverage, I feel like, a lot of what AWS has to offer out there. I mean, do you have like any best practices or tips or anything you recommend, Honorio? You're kind of more in like a leadership role, right, within the software development team? Do you have like a team beneath you that you're able to kind of recommend some best practices to? And is that like your design overall, is you like to make use of immutability and the ability to design an application that's able to scale?
Yeah, I can't say as I'm in charge of anything, but thank you. That's okay. Yeah, it's funny. I asked some of the Erlang folks one time. I said, what they do is they have processes, and each process is kind of self-contained and independent and isolated from every other process. So if I want to get data from one process to another, I have to send a message from one process to another, which would be kind of like if I was like sending an email from one person to another. It's the same idea, right? It's like there's no guarantee they're going to get it. It's just like I have to do it that way.
Mm-hmm.
And I said to them, how do you know a message is delivered from one process to another? And they said, you don't. And I thought, well, that's an interesting observation. And so what you have to do is you have to build your system in such a way that if you need a message sent from one process to another, or in the case of scaling up like AWS, like, hey, I need this database value propagated to these other replicas, and you have to build it in such a way that you don't assume that those other replicas are going to be available or those other processes are going to be available. So you need to say from the other process, send back the acknowledgement that you got this. And, it changes the way you engineer things when you think of things in that way, that like, hey, I can't just assume I can always reach so-and-so. I have to allow for the fact that there may be failures, that maybe for some reason it's somebody took it offline, somebody tripped over the power cord or something, and I have to allow for that. I have to allow for the fact that there could be failures. So like I say, to me, I'm repeating myself, but it does dovetail very nicely with this idea of high scalability, because I haven't engineered things in such a way that I am relying on the fact that, this other process is going to be there. Now I don't have that coupling anymore. I don't have that coupling of, hey, if that other process is near my first process will fail, because I'm not engineering it in that way.
And that kind of feeds back into the whole thing about, I feel like a lot of times in dev, in like the early stages, companies just naturally people want to make it look like everything is going smoothly. And so they always give dev the best case scenario. And if something breaks, they can say that, oh, hey, it's fine that it broke because, this instance went down. So like we don't need to worry about that because someone just broke it in dev. But it's like, yeah, well, that'll eventually happen in prod too. I'm sure pretty much anyone who'd be listening to this has probably heard of Netflix's Chaos Monkey, but I feel like that's one of those things where you kind of need those types of solutions. You need to make sure that you're actually testing the edge cases. I guess for context, for anyone who's not aware, Netflix has this program called Chaos Monkey that basically is just a program that randomly deletes things. That makes it so that every system they have needs to be written with that kind of resiliency in mind, because the devs know that at any point, anything could just be terminated because they have a process that literally just terminates things at random.
Yeah, that's really fast.
Yeah, exactly. And, and to kind of bring it back to what's, more you guys' bread and butter, if I code in such a way that I assume that I don't have to write a value down to a database, right? And I'm holding this value in memory, I'm holding it there for 5-10 minutes, right? And all of a sudden my machine is gone, and that value is completely lost. And, so I have to, as a developer, I have to say, okay, first chance I get, I'm writing this down to a database so that if I have to restart things, if this process goes out, which doesn't, honestly, you guys would know better than I would, but I don't think it happens all that often, but it's not impossible either. It's the difference of thinking of like, hey, this is always going to be available, I'll never fail, and wait a minute, it might fail. I better think about this, and how do I respond to that? How do I make my code such that again, that if I decide I'm going to take this down, I won't have a problem.
Yeah, and that's also, you talk about databases, that's for like the data storage thing, but you mentioned also things like, how do you guarantee that a process gets a message. And at the end of the day, like you said, you kind of can't. But
Right.
having things like using queues,
Yep.
go in AWS, SQS, maybe putting the message on a queue, so that that hopefully something will pick it up down the road. Like you don't have to worry about your destination being there this second. It's when your destination is able to do it, it should do it. It'll pick it up off the queue. And then it also plays into the question of idempotency. Okay, you don't only have to worry about you don't only have to worry about will the message get there. You also have to worry, if I retry this, will it get there multiple times? So
yes, exactly. That's an excellent point.
Yeah, I've certainly seen, at least with some applications that I've worked with clients, it's like even them using a table for tracking, I guess, state of that case, in terms of like if a message was received, sent, if it failed, if it needs to retry it, or if it was, if it's successful, tracking the state of requests as well is something that kind of prevents I guess a level of like deduplication, I guess, in a way of like preventing that, messages are going out twice. So adding checks in place to see if requests were successfully sent or need to be resent because they potentially failed. Definitely something I've seen as well out there. And I've seen people use Dynamo for that. I'm not 100% certain if that's maybe the best use case of Dynamo, but because as the table grows, it does get a little slower. But yeah.
Just on that note, there's actually a neat practice going on in the industry with the immutability of not caring to send it again, and storing it twice. It uses actually I don't know if it's Snowflake or one of the other big data processors or whatever. They don't care if they store it twice the way that they do it, and it actually uses up a lot less compute to have to figure out if it actually was stored, right? If that message was received, than it is to just pull out the last one. So storage is cheap now, so it's okay if it gets written twice, is kind of the idea. Just an interesting thing to think about there with immutability or indemnitancy.
Yeah, and that's, I think, one of the big things, one of the big tenets of, I feel like, the NoSQL philosophy. You're basically trading computing power for storage when you do stuff like that, which there's always going to be a trade-off. It's just what works best for your application and your use case.
There was I would see again. I'll see if I can find the link and share it with you, so you can put it in the show notes. There was an article a few years ago called "Accountants Don't Do Books in Pencil," and basically his point was that we as developers are okay with, like, hey, I'm going to modify this value in the table, but really we shouldn't. What we should be doing is figuring out a way to change the value such that we don't lose the history of it. And storing stuff in NoSQL databases. I mean, Facebook doesn't ever go back and modify things as far as I know. What they do is they add like a correcting entry to the database or a changing entry to the database, but the old one is still there. And so what they'll do is just march forward through the database, and here's the sum total of all these changes, and this is what I show you. Which is very interesting. And like you say, because storage is relatively cheap, it's not as bad as it probably sounds. And in fact, in a certain sense, it can make certain operations a lot easier. Like, hey, I'm a user and I want to go back to what this looked like 2 weeks ago for some reason. Well, here you go. Here is 2 weeks ago. Makes it a lot easier.
Your legal and auditing teams will love you for it too.
Very true. Very true. Yeah, I say to me, it's I kind of go back to the example of, and I'm probably the only one on this call enough to remember, but when they first started having e-commerce sites, they'd always put the button on there and they would always say, do not click this twice. And the reason being that the web basically had no way of preserving state. Like, I've already clicked it. There was just no way to remember, hey, somebody already clicked this once. And the flip side of that was that it scaled incredibly well because I didn't have to worry about state. I didn't have to worry about what has somebody already done. I don't care. As far as I'm concerned, every interaction you have with this web server is brand new, and I have no record of anything. And so that scales incredibly well because I don't have to worry about keeping hold of, like, hey, I did so-and-so before, I did so-and-so before. So the web has always been kind of stateless. Mm-hmm. And when we talk about, like, scaling up instances in AWS and stuff like that, the more stateless you can make it, the better things will scale, because you don't have that coupling of like, oh, I need to remember that this other instance is in this state, but this instance is in this state. I don't have to worry about that. It simplifies things tremendously.
Yeah, that's a really good point. I mean, speaking of, like scaling in AWS, it's certainly something that I feel like they've really excelled at with all their different services. I mean, both ECS as well as, EC2, but trying to identify like applications that are able to scale, that's always high on our hit list in order for providing a solution. If we're able to speak with the developers before providing, some suggestion in terms of what we're recommending, it's always whether or not knowing that your application is asynchronous, because they might have scaling needs. And to Kevin's point, I think that is definitely one of the biggest hiccups that we see in some cases, is that they potentially have scaling needs, but they haven't written their application in a way that allows them to scale natively. So it's really nice hearing, your point of views on this, Honorio.
Oh, thank you. Yeah, and that to me is really something that I think, and I'm sure you guys do when you consult your clients and stuff, you've got to think about, like, you can't just build it the way you used to build it, because that will not scale. Mm-hmm. And ultimately, one of the biggest advantages you've got with AWS is like, hey, I want to throw more machines at this, I want to put more customers, and I can do that very easily with AWS, but not if I built my application in such a way that I make it hard for myself,
Yeah. And just, it allows for you to kind of take more advantage of what AWS offers, and really kind of can overall drive price down if you're able to make use of like spot instances for certain things, if you're able to, move queuing into like SQS, rather than another queuing mechanism that you're maybe, tracking on a different machine or something like that. But yeah, it allows for you to really leverage what AWS has to offer.
I feel too often.
Right, and that's...
Sorry, go ahead.
Go ahead. Sorry.
I was going to say, I feel too often you see executives who say, we want to move to AWS. We want to move to the cloud, because they just hear that that's something they should do. It's the buzzword. They want to be able to say that their company did it. But if all you're doing is moving what you're currently running on-prem into the cloud, all you're going to do is end up paying more money for effectively the same thing. Maybe a little bit better redundancy, like a bit better recovery. Mm-hmm. Moving to the cloud requires kind of a change in how you go about your whole general approach to software. And especially for companies that have a whole bunch of legacy code, that's probably going to mean some updates. And that can be scary for a lot of companies.
Yeah, that's part of the reason I invested this topic in the first place, because to me, to say I just take what I've got right now, which is predicted and everything's sitting on one machine and everything is, everything can talk to everything else and all this, and I'm just going to take and move it out to AWS. You're missing a lot of the advantage of moving to that cloud platform because you're not in your application, or you're not modifying your application in such a way that you can take advantage of, the scale up abilities. Your application in such a way that you couple things together and you can't scale up easily. So to me, yes, immutability, state, that kind of stuff is intrinsic to using a system that allows you to scale up and using it well.
Yes, I feel like every discussion I'm involved in eventually comes back to this point, but I got to take my shots. I always got to take my shots for the multi-cloud people. This is another reason why I don't see multi-cloud as really working. If you're going to use a cloud platform, you're going to want to make use of the most of everything that cloud platform can provide you. Like, that's how you're going to get the value there. If you're trying to, you have these companies that are, multi-cloud. So many times what multi-cloud means is we're just going to be so generic that we're not going to make use of these cloud services so that we can drop our stuff in wherever. And at that point, you're kind of, again, you're not really doing cloud. You're just doing on-prem hosted on someone else's servers for the sake
might as well buy a
compatibility.
VPN. Yeah. Sorry, I didn't mean to cut you off there. Yeah, I just got to agree into that. You're not taking any advantage of what the cloud has to offer, whether it be in terms of, I'll bring up the fact of infrastructure as code. Regardless, you're going to need to modify your application in a way that allows for you to utilize the environment you have it in. Otherwise, moving something to AWS or to Azure or GCP, that's fairly trivial. You can just plop a machine out there and run it. But again, yeah, to your point, you're going to pay the same, if not more, maybe a little higher resiliency. But yeah, we are kind of coming close to time. I know we started a little later, but I do want to give everybody a chance for closing thoughts or anything that they wanted to touch on while we still have some time here, though.
Just wanted to say something, throw something out there. I've had the chance, not just from the back end, but also architecting, working with developers in the front end, and I feel like the trend is now it's now more important for the idempotency and storing state, things like that, from a front end perspective than it is from the back end. AWS has made it a lot easier, but once you want to get your app going really fast, really resilient, it's now become more of a front end thing and managing state there. I don't know, so it's interesting to me.
I can definitely agree with that, and I think a lot of these new web technologies are actually really great for that. And
yeah,
it's great from a operational and compute perspective, because you talk about scalability, doing offloading the processing to the user's browser.
Yep.
You can serve pretty complex applications as basically static sites at this point, maybe with a few APIs to do some data transformation.
And it's gotten really fancy, like service workers, things like that on the front end. So it's just more complicated too. And I feel like it's kind of easy now with the cloud and the back end, and what AWS provides and all of that. And now to really make things really fast, and it's now on the front end side, and it's getting kind of complicated over there. Just wanted to say that.
One of my favorite setups that I've kind of worked with for my own projects has been Amplify with AppSync, which is basically you have no server. You talk about serverless and you frequently think about Lambdas, but you can write pretty much a fully legitimately serverless application where there is no back-end code running whatsoever, where you use managed GraphQL service. which returns your data from a Dynamo database, and all of the AppSync can handle the authentication stuff for you. You just say what groups you use your Cognito for user authentication. You say, these groups can make these calls with these parameters, and you do all your processing on the front end.
Yeah, it's really just the validating authentication, right, is in the back end. And yeah.
Yeah, like I said, I think if people take their old synchronous applications and say, "Oh, I'm going to move up to the cloud," they're missing a lot of the advantage of the cloud, because that synchronous behavior is limiting. It's very limiting. And when you were saying earlier, when you start thinking in terms of asynchronous, like I can do this and I don't have to wait for this other thing, then you really can scale. Then you really can make your application growable. Where you can, like, instead of handling my customers at a time, I can handle 100 customers at a time. But I didn't build it in such a way that I assume that everything's going to be synchronous.
Yeah, those are some really great points. I do want to say, yeah, we kind of are here at the 30-minute time. We are welcome, I guess, to continue talking if we would like to, but other than that, yeah, I want to thank everybody for being here today. I think it was really overall we had a good discussion on this. A lot of interesting viewpoints on the 3 topics we covered, plus we kind of delved into a few others. But again, yeah, anybody have anything else they would like to say? But again,